Imagine waking up one morning and seeing a fiery ball streaking across the sky, brighter than the sun, faster than a bullet. Within seconds, it slams into the earth, shaking the ground like a billion earthquakes combined. The sky turns red, the air burns, and the world as we know it begins to collapse. It sounds like a Hollywood movie, doesn't it? But this scenario isn't fiction. It's a possibility scientists take very seriously. So here's the chilling question. If a massive asteroid were to hit Earth tomorrow, could we survive it? To find the answer, we need to dive deep into what these space rocks really are, how deadly they can be, and whether humanity has the power to stop one before it's too late. The cosmic danger. Imagine space as a giant highway filled with drifting rocks, some as small as pebbles, others as large as cities. These are asteroids, ancient leftovers from the formation of our solar system billions of years ago. Most of them float safely between Mars and Jupiter in what's known as the asteroid belt. But here's the catch. Some of these rocky wanderers escape their orbit and drift closer to Earth. These are called near-Earth objects, NEOs, and they're the ones that keep scientists awake at night. NASA's Center for Near-Earth Object Studies currently tracks more than 30,000 of them. While most are harmless, even one large enough, say 1 kilometer wide, could change the course of human history in a single day. History already gave us a terrifying example. Around 66 million years ago, an asteroid about 10 kilometers wide slammed into what is now Mexico's Yucatan Peninsula. The result? The Chicxulub crater, a massive scar on Earth, and the extinction of the dinosaurs. That rock wiped out 75% of all life. Could that happen again? Unfortunately, yes. Earth still crosses paths with millions of space rocks, and even though technology helps us track most, some still sneak by undetected. What happens when an asteroid strikes? Now imagine this. A gigantic asteroid enters Earth's atmosphere, racing faster than a speeding bullet, over 20 kilometers per second. The air in front of it gets compressed and heated until it glows like fire. For smaller asteroids, this fiery entry burns them up, giving us the shooting stars we sometimes see at night. But when a giant asteroid comes through, it doesn't burn, it destroys. The moment it hits, the energy released is beyond human imagination. The explosion equals millions of nuclear bombs going off at once. The ground quakes, the air roars, and a blazing fireball erupts into the sky. If it hits land, it carves out a crater miles wide, vaporizing everything around it. If it crashes into the ocean, it sends towering tsunamis racing across continents. For perspective, in 2013, a small meteor only 20 meters wide exploded over Chelyabinsk, Russia. It shattered windows and injured more than 1,500 people. Now imagine something 1,000 times bigger. Cities, states, and entire countries would be wiped out instantly. But as bad as that sounds, the real nightmare begins after the impact, the aftershock. The first few minutes after impact would look like the end of the world. The asteroid's blast would ignite forests, flatten cities, and send debris high into the atmosphere. The shockwave would travel around the planet, toppling buildings thousands of kilometers away. Scientists estimate that a 1 kilometer wide asteroid would unleash over 100 trillion tons of TNT worth of energy. Everything within hundreds of kilometers would be vaporized. Temperatures near the impact zone would reach thousands of degrees. In 1908, a smaller asteroid exploded over Tunguska, Siberia, flattening 2,000 square kilometers of forest. Trees were knocked down like matchsticks. Luckily, it hit a remote area, but had it landed over a city like Tokyo, London, or New York, millions would have perished in seconds. And even if you survived the initial blast, you'd soon face the next terrifying phase, the long, cold darkness that follows. The long, cold winter. Imagine standing outside after the impact. The sky is no longer blue, it's black. The sun is hidden behind a thick veil of ash, dust, and smoke rising from countless fires. For weeks, no sunlight reaches the ground. This global darkness, known as impact winter, could last for years. Temperatures would plummet, crops would fail, forests would die. Without sunlight, photosynthesis stops and plants can't grow. Without plants, animals starve. And without animals, humans follow. Scientists studying the Chicxulub impact estimate that temperatures back then dropped by as much as 26 degrees Celsius. about 47 degrees Fahrenheit, for several years. Oceans cooled. Phytoplankton, tiny sea plants at the base of the food chain, died out. If this happened today, food production would collapse. No sunlight means no farming. Supermarkets would empty in weeks, and nations would struggle to feed their people. Civilization itself could crumble, not from the impact, but from starvation and chaos afterward. Worse still, the atmosphere would become toxic. The asteroid strike would release gases like sulfur dioxide, causing acid rain that poisons rivers and soil. Massive volcanic eruptions could follow, adding more ash to the sky. Earth would turn into a cold, dim, hostile planet. Can we see it coming? Here's the good news. Unlike the dinosaurs, we have telescopes, satellites, and scientists. NASA, the European Space Agency, ESA, and observatories worldwide constantly scan the skies for potential threats. NASA's DART mission in 2022 proved that we can actually change an asteroid's path. A small spacecraft intentionally crashed into the asteroid Dimorphos, successfully nudging it off course. It was a historic first step toward planetary defense. Still, there's a catch. Smaller asteroids, like the one that exploded over Chelyabinsk, often go unnoticed until it's too late. Even large asteroids require years of preparation to deflect. That's why early detection is critical. By 2025, the new Vera Rubin Observatory is expected to revolutionize asteroid tracking, finding thousands of NEOs faster than ever. NASA estimates we've already identified about 95% of asteroids larger than 1 kilometer. But that still leaves thousands we haven't seen yet. The truth? If a large asteroid were discovered heading straight for us with only a few months' notice, there might be nothing we could do but prepare for impact. Can we stop it? Imagine the world learns an asteroid is on a collision course with Earth, and it's only 10 years away. Panic erupts, but scientists start working on solutions. The most realistic defense strategy is deflection, changing the asteroid's orbit so it misses Earth. The DART mission proved this idea works, but a much larger asteroid would need multiple hits or even nuclear-powered impactors to push it off course. Other futuristic ideas include a gravity tractor, a spacecraft that hovers near the asteroid, using its own gravity to slowly pull the rock off its deadly path. It's slow but accurate. Some scientists even propose painting the asteroid white to change how sunlight heats it, subtly altering its orbit over years. But here's the challenge. All of this takes decades of planning and cooperation. Countries would need to share resources, data, and technology on an unprecedented scale, and one miscalculation could spell disaster. If an asteroid is too large or too close, even our best technology might fail. Then survival becomes the only option. If deflection fails, let's say deflection doesn't work, the asteroid is coming and there's no way to stop it. What then? Survival becomes the mission. Governments could build vast underground bunkers capable of housing thousands. These shelters would need food, water, medical supplies, and renewable energy. They'd be designed to withstand earthquakes, radiation, and years of isolation. It sounds like science fiction, but projects like the Svalbard Global Seed Vault in Norway already exist to preserve plant species for a future crisis. Expanding this idea could help humanity rebuild once the skies clear. With sunlight blocked, traditional farming wouldn't work. Instead, we'd rely on hydroponic systems, which grow plants indoors using artificial light and nutrient-rich water. Nuclear or geothermal energy would keep shelters running, since solar power would be useless in darkness. NASA already tests similar systems for Mars missions, so we have a head start. Survival would require nations to work together like never before. Sharing food, technology, and shelter space could determine whether civilization continues or collapses. The United Nations Office for Outer Space Affairs already manages global asteroid response plans, but expanding them would be essential. It's not impossible, just incredibly difficult. The 2020 pandemic proved humanity can unite under pressure, but it also revealed how fragile global systems can be. Surviving an asteroid impact would demand even greater coordination and trust. Lessons from the past. Earth's surface is scarred with reminders of past impacts, proof that asteroid strikes aren't rare accidents, but part of our planet's story. From Tunguska, 1908, to Chelyabinsk, 2013, we've seen smaller versions of what could one day happen again. In 2021, NASA ran a simulated asteroid impact scenario to test global readiness. The outcome? Even with 6 months warning, humanity struggled to respond. Communication failed, governments hesitated, and misinformation spread faster than solutions. The lesson was clear. We need better preparation now. The strength of the human spirit. Now picture this final scene. Scientists work around the clock, engineers launch last-minute missions, and ordinary people help each other prepare. Fear fills the air, but so does determination. Humanity has always faced impossible odds, from ice ages to world wars, and survived. An asteroid impact would be our ultimate test. It would destroy cities, reshape continents, and threaten our species. But it could also unite us like never before. Because deep down, humans have one incredible advantage: hope. The drive to fight, rebuild, and survive has carried us through every catastrophe, and it could do so again. Preparing for the future. Let's look ahead. The year is 2050. Humanity has learned its lesson. Every country now contributes to a global asteroid defense network. Advanced telescopes scan the skies 24/7. Deflection missions are ready to launch at a moment's notice. Underground cities are equipped to protect life for years if disaster strikes. This vision isn't a fantasy, it's a necessity. Scientists estimate that an asteroid big enough to cause global devastation hits Earth once every few million years, while smaller, city-killing impacts happen roughly every few centuries. That means we're not immune, just lucky. We can't stop the universe from sending rocks our way, but we can stop them from destroying us. Funding planetary defense, improving early detection, and fostering international cooperation aren't optional, they're essential. Every telescope, every mission, every ounce of preparation is an insurance policy for our survival. Because the question isn't if an asteroid will hit Earth again, it's when. And when it does, our survival will depend on the choices we make today. In conclusion, so could we survive a massive asteroid impact? The honest answer? Maybe. If it's small, we can endure. If it's big, we'll suffer, but we might rebuild. If we detect it early enough, we can stop it entirely. But if we ignore the threat, we could vanish like the dinosaurs. The universe doesn't care who we are. But unlike the dinosaurs, we can see danger coming. We can prepare, we can fight back. And maybe, just maybe, when the next giant rock hurtles toward Earth, humanity will be ready to prove that survival isn't about strength. It's about intelligence, unity, and hope. If you found this helpful, make sure to subscribe, drop your thoughts below, and keep learning with us. More inspiring content is on the way. Thanks for your amazing support.